Hello and welcome back to another math video. Today we will be covering quadratic equations in Vertex form. By that will be the formula that you'll find them in, the information that goes into that and that can be taken out of it, as well as how that can be used to graph that information, or how you can use a graph to put that into the equation. In Vertex form, our equations will be looking like f of x, or y, depending on the equation, is equal to a times x minus h squared plus k. The important variables that we will be looking at will be a, h, and k. Of these, h and k are the most important ones, but a still has something to play. A determines the orientation of the graph. It determines if the graph opens upwards or downwards. It also determines how stretched or compressed the graph is. For example, for the equation, let's say y equals, I'll just say, actually I'll do it like this. For an equation that has maybe an a value of 4, your graph might end up looking like this, where you have a very steep parabola. Whereas in contrast, if I have, I'm going to do it over here, if I have an a value of 1/3, my parabola is going to be a lot steeper. It's going to be a lot wider, a lot more spread out. I believe it's compressed. The words are a bit counterintuitive. Wow, that was bad. The words are a bit counterintuitive in my brain, but you get the idea, though. Sorry, my graphs are terrible. So that is what the a value stands for. It will, and I can show you a couple negative ones as well. If I say a equals just -2, my graph is going to end up looking kind of like this. It'll be a bit more stretched, but it's going down. I might show a Desmos example, but for now I'll just show it as visual graphs. So moving on from there, we'll be looking at what the h and k values represent, because that is actually the biggest, most important part of vertex form. So when looking at vertex form and looking at h and k specifically, those are super important because those make up your vertex. If we recall, our vertex is a coordinate point, and in that coordinate point, it is made up of h, comma, k. You get these directly from your equation. So if given the equation, f of x is equal to x minus 3 squared plus 4, my vertex is just going to come straight from this. It's going to be my x, comma y, my h, k. So my vertex is going to be 3, 4. Now, some of you might be asking, where did the negative go? Why did the negative here not carry over into my vertex? That's because the negative is part of the formula. That is a set part of the formula, which means that when I plug a number in for x, it's going to flip the sign. So because my vertex is positive, when I plug it in, it's just going to become negative. If we look at the k doesn't have that same problem. The k just has a plus next to it, has a plus in front of it. So whatever our y value is of the vertex, that value just goes straight in to our formula. We don't need to change it. So that'll work when we deal with negatives. So for example, if I say y equals x plus 3 squared minus 7, my vertex, again, is going to come straight from my formula. It's going to come from my h and my k. My vertex is going to be -3, -7. The reason for that is because, again, I have a negative in my formula. My formula is x minus h, and then just a plus k. This x minus h means that when I plug in this -3, it's going to flip to a positive. I flip the sign in here, as opposed to when I'm working with a -7. Because there was just a plus k normally in our original equation, when I take this -7 from my vertex, I just plug it in directly. I don't need to change the sign on this -7, I just leave it as is. I'll show us a quick example of how to do it the other way. So for this case, we're going to be writing vertex form equations given this certain amount of information. And so we're just going to be plugging these numbers directly into our formula. If we recall, the a1 is simple, it's just part of our formula. When we look at our vertex, it's important to know what is the h And what is the k? Remember, our vertex is given as hk. The h is the x, the k is the y. So when I plug it into my first equation using the top part, I'm going to say f of x, or y, doesn't matter, is equal to 3 times x minus a negative 2 squared plus 5. If we note a couple things here, the square, I'm just going to get this out of the way, the square is always a part of this equation. If you do not include the square here, that's wrong. The square is what makes it a parabola, otherwise it'll just be a linear equation. It'll be a completely different line. Without the square, it looks like a line. With the square, it looks like a parabola. So the other big thing that we might be noticing is I put a double negative here. That is because in our original equation, in our original formula, it is x minus h. So because my h is a negative here, I have to do a negative, and the double negative is what creates a positive. So when I simplify this, I'm going to say f of x is equal to 3 times x plus 2, again, got to keep the squared, plus 5. Simple as that. You're just plugging in to the formula. Now, let's do the next one. Let's work with these numbers instead. I'm going to say y this time, not that it matters, is equal to negative 2 times x minus 9. Again, I'm just plugging in my h, squared minus 13. And I'm just plugging in my k. Simple as that. No need to throw in any extra steps. This is just the a, this is just the h, and this is just the k. And that would be my vertex form equation. Alright, so the two examples that we're going to be covering at the moment is f of x equals x minus 3 squared plus 4, and y equals 2 times x plus 2 squared minus 5. And so, let's pick out the information from our equations in order to turn them into a graph. To start, for this equation, what is my a value? My a is going to be equal to, it's the number in front of the parentheses. If we don't see it, it's not 0. There actually is a number here. It's a 1. Because it's 1 times this, which means this isn't going to change. My a value is 1. Now, for my vertex, which is going to be my starting point, it's again given by h and k. So my vertex is going to be 3, 4, which is where I'm going to start. So my coordinate that I'm going to start with when I graph this is at 3, 4. And forgive me for how really bad my tick marks on my graph are. Okay, so from here, I'm going to do, it's a little cheat I can do. You can normally plug in points, but what I like to do is I like to go to the point immediately after in both directions. So I'll go one to the right, one to the left, and go up or down depending on my a value. Since my a value is positive 1, I'm going to go to the right one and up 1, and I'm going to go to the left one and up 1. And from there, I'm just going to graph. And forgive me in advance for how bad this parabola is. I'm not very good at drawing these things. So your graph will look something like that. And you only really need the 3 points to make it. Kind of like when you're graphing like a y equals mx plus b equation. You only need 2 points. This point and maybe another one, and then you can just draw a line through them. Same logic for parabolas, you just need 3 points. And we don't have to be the most accurate things in the world. We just, in this case, we're going to be close enough. Okay? Moving on to the next one, y equals 2 times x plus 2 squared minus 5. Let's label a, b, and c, or not a, b, sorry, a and our vertex. Our a value is the number in front of the parentheses. It's the 2. So we have 2. What is my vertex? Actually, I'm going to do it like this. It's 2. My vertex I get from h and k. Vertex, I get it from h, and I get it from k. Something to keep in mind, if we notice in the previous problem, when I took this negative 3 out of the parentheses, it ended up being positive. Whatever's on the inside of the parentheses will be opposite when I take it out. So since this is a positive 2, that means in my vertex it's going to be negative 2. And my k value just stays the same. So my vertex is negative 2, negative 5. That's my starting point. Negative 2, down 1, 2, 3, 4, 5. So from here, I'm going to do the same trick that I did in my last problem to find my next 2 points. I'm going to use the, you can't see me air quoting, slope. So I'm going to go over 1 in each direction. So I'm going to go to the right one and go up how many? 2, because that's what my a value is. over 1, up 2, over 1, up 2. So now when I graph this, it's going to be, we're going to pretend I didn't do that. It's going to be a lot steeper than my previous equation. And I know mine look a little quirky, but as a note, when you're doing your parabolas, you want the shape to be like a U. We do not want it to be V's, because these are two different graphs. This is an x squared graph, it's a parabola. This is an absolute value graph. So just be careful about that. I know mine look a little rough, but as long as you make sure that these are U-shaped. Understood? All right, let's move on to one more example using a negative. So the equation that we're going to be graphing is f of x equals negative 3 times x plus 4 squared plus 6. So we're going to start the same way. We're going to figure out what our a value is, and we're going to figure out what our vertex is. So to start, the a value is just the number in front of the parentheses. That is this negative 3. For the vertex, again, that comes from the h and the k. So when I write out my vertex, it's going to end up being negative 4, 6. Again, when I take it out of this parentheses, it becomes the opposite of what it is. Since it's a positive 4 inside my equation, inside this parentheses, when I put it in my vertex, it's actually negative. And again, my k just stays the same. So my vertex is negative 4, 6. That will be my starting point. 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. This is my starting point, my vertex. Now, when we look at our a value to determine how to graph the other 2 points, I'm going to use my trick again. I'm going to go over 1. You're only going over 1 point and then going up or down depending on the a. I'm going to go over 1, down 3. I'm going to go over 1, down 3. And I'm just going to graph this. If you notice this time, the graph is negative because my a is negative. My graph is going down because my a is negative. So that covers it for graphing the vertex form equations. Now we're going to take the actual vertex form graphs and plug them into our equations. Alright, so for this section, we're going to be creating our vertex form equations when we're given graphs. I apologize in advance for my admittedly very terrible graphs. I'm still getting used to this pencil, but we're going to work with what we got. Alright? So, for the first one, again, our vertex form equations are given as f of x is equal to a times x minus h squared plus k. So the things we need to know what a is, and we need to know what our vertex is. As if we recall, our vertex is hk. So let's do the first one. Figuring out our vertex is simple enough. That is the highest or lowest point of the graph, the minimum or the maximum. So when we look at this graph, we can tell that our vertex is up here. Our vertex, which in this case is a max, is 1, 2, 1, 2, 3, 4. It is at 2, 4. I don't know why I'm counting. I made the graph. 2, 4. And what is my a value? I can check by doing the little slope trick that I showed us in the last section, where I'm going to go over 1 and down until I get to a point. So over 1, down 1, 2, 3, 4. My graph is really bad, but I did mean for this to be my point, because it's the solid point on here, so I apologize. So I went over 1, down 4, or if you want to think about it in terms of slope, down 4 over 1. So my slope is negative 4. Or my a value, sorry, my a value is negative 4. So when I plug this into my vertex form formula, I'm going to say f of x, or y as you recall, is equal to negative 4 times x minus 2 squared, because I flipped the symbol, I flipped the sign when I put it in my equation. So this might have been a positive 2, but when I put it into my vertex form formula, it's going to become a negative. And then plus 4. That's my equation for this graph. Let's move on to this one. It's a lot wider, so that might give you an idea of what our a value is going to be. So again, we need to find our a value and our vertex. So our vertex should be simple enough, right? It is just the lowest or highest point. This is my low point, my minimum. And it is given as negative 1, 2, 3, negative 1, 2, 3, 4. So negative 3, negative 4. My a value, let's check. I end up going down 1 and to the left 3, or down 1 to the right 3. Or sorry, I don't know how to speak. I'm going up 1 and to the right 3, up 1 and to the left 3. So my a value is 1/3. I'm stretching it out. So it actually works better to go like the vertical or horizontal, or the vertical first. So here I went down 4 to the right 1, down 4 to the left 1, down 4 over 1. Here I'm going up 1 over 3, up 1 over 3. So that is where my a value comes from. So when I plug this into my formula, I'm going to say y this time. Y equals 1/3 x plus 3 squared minus 4. Forgot the parentheses. Squared minus 4. So again, if we notice my -3, my x value here, it might have been negative in my actual vertex, but when I plug it into my formula, it becomes the opposite. Now moving on to our last graph, again, we need to find the a and the vertex. My vertex is my lowest or highest point, so here it's my lowest point at 0, -3. My vertex, 0, -3. And my slope, or my a value, I'm going up 1, 2, 3, 4, 5 over 1. Up 1, 2, 3, 4, 5 over 1. So my a is positive 5. So when I plug this into my formula, I'm going to say f of x, or y, is equal to 5 times x minus 0 squared minus 3. And if you want to simplify this, you'll end up getting f of x is equal to 5x squared minus 3. Sometimes you'll get equations that look like this, and you might wonder, wait, where's my x value? Or where's my parentheses? What's the x value of my vertex? Because you don't have a parentheses, that means that you don't have, like, your vertex is going to be somewhere at 0. Your x value, your h value of that is going to be 0. And that's fine. It happens. So, thank you for watching the video. I hope it was helpful. I apologize again for my abysmal graphs. Hope everyone has a good one.